One of the more common security vulnerabilities for web-based application is cross-site scripting. I think most of you have heard the term, but who is familiar with what it means exactly? No one. Nice.
Cross-site scripting means injecting a piece of code to a form.
Yeah.
Cross-site scripting means injecting a piece of code through a form, for example, via an input.
Yeah, exactly.
An input field.
And there is that's the first part, and the second part oftentimes is because you want that this code is executed in the session of another user. That's a very important part because you as a user, I as a user, I am able to run whatever code I'd like in my browser. It's very easy to just open the developer tools and just type some random code. So that's something you can't prevent anyway. It becomes dangerous if you know that there is some, for instance, some API that you can't access because you don't have the sufficient rights to call that API. But you know that, for instance, a support employee can access this API, and you want to execute or invoke an API call. If you were able, for instance, to submit a ticket, and inside that ticket, indeed inject some code in such a way that if a support employee opens the ticket, the code will automatically be executed, then you have a successful cross-site scripting attack. So it's the ability to execute code in another user's session. For this to work, you need to find some place where user input, something that the user can define, is added into the page without any encoding. The preventing cross-site scripting actually is pretty easy. Just make sure that all values are properly encoded. Is the value used in HTML? Use HTML encoding. Is the value used in an HTML attribute? Use HTML attribute encoding. Is it used inside JavaScript? Use JavaScript encoding, etc. So in principle, it's very easy. But of course, it's also very easy to miss because you have to think about this for every field, for every user input. Luckily, WAM automatically does this. If you put a label somewhere on your template, it automatically makes sure that it's HTML encoded. If you put some value in an input field, it automatically uses the right encoding for that. But of course, Web also provides an option to create widgets. And if you build your own widgets, then this is your responsibility. Who here has built some widgets, either built some widgets or added some custom code to a page? Yeah, most people. Okay. I'm going to give a very short demo of a cross-site scripting attack. I believe I already have it working. What I've built here is a very simple application where if I enter something in here and I press refresh, it's duplicated in the panel underneath. I believe right now it's secure. Yeah, right now it's secure. I entered some HTML, but this HTML is itself HTML encoded. Why is it secure? That's because in this code, can everyone, let me zoom in a little bit. In this code, this by the way is WEM script. This is the same script that you use for building widgets, but you can also add some WEM script ad hoc. In this code, I said with the equality sign, print this value. But if you use the equality sign, it automatically uses HTML encoding. That's a decision we made by design. If you don't really think about it, then the default behavior should be the most secure option. But sometimes you might want to actually put the literal value of this field in the HTML and bypass the HTML encoding. You can do that in WEM by replacing the equality sign with raw. Didn't I save? You didn't say anything. Okay. So as you can see, now it's just a literal HTML. Which also means I can put some scripts in here, and it will execute these scripts. There happens to be a button in here, and I know the script that's been executed if you press on this button. This button is a button that shows an overlay. It's just a follow button exit. But if I go to my developer tools, and I go to the console. In the console, you can execute random JavaScript. So if I put an alert, 1, 2, 3, you get an alert. Like I said, a user can do anything in their browser, and you can't prevent that. This is the script. I thought this was the script. It doesn't do anything. It has changed. Okay, let me find out the script itself. Then I have to tweak it a little bit. Can you see the difference? Oh yeah, it's different. This is the script, and if I run this script, it presses that button. Or rather, it invokes an AJAX call to the server, which is equal to what would be sent to the server if you press that button. So what I can do now is I can put this into a script tag. Now if I hit refresh, it automatically follows that button. And now I have a problem, I realize, because as soon as I close this overlay, it will refresh the page underneath, and that will automatically, I think, reopen. Yeah. Okay. Okay, so this is a problem, and you already saw one measure that we did to prevent this. There is something else that we do to prevent this, which is, as far as I know, pretty unique to WAM, and that's that we we mirror the state of this page, of the current page of the application, on the server. And if a request is sent to the server and the server validates it against the current representation of this page, and it finds out that the user should not be able to generate that request, then we just ignore it. The normal logic that I often see in applications, if an AJAX call is sent to the server, it checks, does the user have the correct rights? Does he have the right rights to execute this? And if so, then it's granted and the request is executed. We don't just check that. We also check, is the user theoretically, from this page, able to execute that command? So if we take that script again, if I run it now, you get this script. But I also added a show panel. If I hide the panel, the button is not visible anymore. And if I run it now, it's just ignored. This is very important because even if, for instance, a malicious or a badly written widget contains a vulnerability, and somehow the user is able to enter some code that is executed from within that widget, that is only able to execute something that is available on that same page and in the same state as where this script is executed. So, for instance, if the page doesn't provide any functionality to make you an admin user, for instance, then you can't inject a script that's able to do that. And okay. And that's something that doesn't only prevent cross-site scripting, but also a very another very common vulnerability. Jesus. The cross-site forgery, let me sketch a scenario. If you are logged in an application, then in the browser your session is open and the server trusts you as a user. In the situation that I sketched, where there is an API that can be invoked by an AJAX call or a GET request or whatever, this call is executed within the context of the current session, and if the user is logged in, then the server trusts this request and validates it against the user rights of the user that's logged in. If the user happens to also visit another website in the same browser, and that website, for instance, does a redirect to your application, doesn't matter if it's in a different tab, then it will reuse the same session, because the same session is shared over multiple tabs in your browser. You know that if you open the modeler and you open the modeler in a second tab, then you don't have to log in again. And this is very common. This means that even if your website isn't vulnerable for cross-site scripting, if there's another website that's vulnerable for cross-site scripting, and the hacker, for instance, knows that there's a reasonable chance that the user uses the same website at the same time. It could be a support system, for instance, and I don't know, MyWem. Then the hacker could bet that eventually there will be a scenario where on the website 1 you get this script that will be executed, which will actually invoke a request to site 2, which will be granted because the session is still open. For this scenario, it's also very common advice to keep the session short, to make sure that the session is closed. So that's why we have this clear session node, which actually clears the whole session history and makes sure that even if you click on back, the user doesn't have the rights anymore. But WEM adds an additional feature for that, and that's this token that you see in the URL. This token is cryptographically secure, so we use a secure random number generator to create this token, and it is replaced and refreshed every time you do something on the page. So every time there's a communication with the server, for instance, I can click here on yes, there's communication to the server, this token is refreshed. When you try to invoke, for instance, this JavaScript code, it also checks that it's called the session version, that the session version token is correct. So for cross-site forgery to be successful, the hacker must also be able to predict this token, and that's virtually impossible. Is this clear? Does it make sense? If there are any questions, please let me know, by the way. So these are some things that we do on a more software level. If you're looking at a more technical level, we try to follow as much as possible the best practices. The best practices change all the time, of course, based on new insights. And sometimes some of these best practices require that you completely redesign some mechanisms, and then we have to decide, well, when will we start following these best practices. Right now, there are a couple of things that we can improve. Those themselves are not vulnerabilities per se, but it's basically the things that I now explained. There is a, let's say, weaker, less secure mechanism in place in the browser that you can fine-tune with HTTP headers, and that's something that we want to improve on in the near future. Which, by the way, like I said, it's completely redundant because it serves the same purposes as the mechanisms that I already explained. But it's something that during security audits, this will sometimes be triggered as very low priority security risks. Well, it would be better if, for instance, you change some values in the content security policy header, for instance. That's a very common header. We don't want this feedback, so we we plan on improving that. But those are very minor things. If we are actually going to look at the for instance, the cookies that are being used, and you see, apart from some pre-existing cookies that already existed, that this is the cookie that is used for the session. So this one is very important. If this cookie, if somehow a user or a hacker gets access to this cookie, he can take over your session. Of course, you get a new cookie every time you log in again, so and it expires, so it's not something that you can use after a month or that you can keep using. But it's very important that this cookie is secure. So we are following a couple of best practices to make sure that this cookie is secure. One of the things that we say is that it is a secure cookie, so the only protocol for which this cookie can be used is HTTPS. This cookie doesn't work on a normal HTTP connection. It also says that it's HTTP only, which means that the cookie is, of course, known between the browser and the web server, but the website itself, i.e. JavaScript, is not able to retrieve this cookie. There's a distinction. Some cookies are able to be accessed by JavaScript or modified. This cookie is only used in the communication between the browser and the server. It is completely hidden from JavaScript. So even in the developer tools, if you go in the console, there's no way to retrieve this cookie. And then we have some addition. Yeah?
Assuming that that'll work with that. So let's say that we are working inside a web application,
Yeah.
and then the user clicks on maybe a redirect link. So does this cookie still remain inside that session, or it is replaced by the new redirect?
If it's a redirect to another website or to the...
Yeah. For example, in one of the scenarios, when we want to have, let's say, a secure payment triggered.
Yeah.
For example, if you want to do a Molly payment,
Yeah,
it goes to the Molly website, right?
true.
Does the payment, and
True.
then even if we try to redirect back to the web application, so
Yeah.
the session is no longer valid, right? So that's what I'm.
The session still exists. The session still exists. But if you redirect back from the Molly payment, then you are missing this token. And even if the session still exists, if you are not able to provide the correct token in the correct scenario, then we still don't give you access to the session.
I have also once tried using the same token, the same URL, but even then,
Yeah.
I detected that this is not
That's
right
true,
token.
because it sees that this session version token was created in a different context, and you can't just copy it to another context. You can't just say, well, I changed the URL to another page, but I use the same token. This token is tightly coupled to the interaction node, actually, that you're currently on.
Yeah, it's clear.
For this reason, by the way, and the same applies for instance, if you have OAuth login or a SAML login where you are redirected to another system. A very common scenario is that you provide a relay state value to the other side, which is either the complete state of the session, or it can be something like a continuation token, which, for instance, gives you access to the state which is stored in the database, and then you can continue more or less from the same perspective as where you left the website. With the introduction of HTTP endpoints in WEM, you can build this for all different kinds of systems. So we already had this built in and automatically handled for OAuth and SAML. But now you can also, for instance, integrate with payment systems and other sites where you have to, or systems where you have to go to another website. There's only one there's one problem. Right now, this is only supported in a Kubernetes environment. So on the shared cloud environment, this option is not available. It is available in the modeler, but if you use it in your application, those HTTP endpoints will not be available for you. So this whole system where you use some relay state, you can build it yourself when you use HTTP endpoints. Yeah, and some other best practices that we follow is we try, and this is something that we get better and better in. We made a lot of progress on this in the last 2 years, and especially in the Kubernetes environment, this is completely optimal right now. Things like X-frame options that you can add to prevent your website from being included in a frame. It still exists. Referrer policy, content security policy, I already mentioned that. Content type options. You can read about this, but the message basically is we take care of these headers. In the near future, there is an option, especially for the Kubernetes environment, to tweak this. So if you want to provide different headers, you can do that. For that, we are building a DevOps dashboard. We are already internally using it, so I might show you a little bit about that later on. But again, we provide this for you, so you don't really have to think about this too much. It can mean that some things that in other scenarios are possible are now disabled in the browser. For instance, we omitted this data property in the content security policy, and suddenly everywhere where you add a base 64 encoded value in an image, for instance, was disallowed. So instead of the image, you just got a cross. So this is something that you have to find the right balance between disabling every feature in the browser and basically rendering the complete website useless, and making sure that we provide a subset which is enough for a web application to run, but still disables as much capabilities in a browser as possible. Because that's where this header is for. You are basically saying these capabilities in the browser should be disabled for this website.